Dominica State College Math 1-1 Final Assessment, Section A, Practice Questions, number 3. The following data is provided with the aim of testing the hypothesis that there was a significant variation in tourist arrival in the year 2022 and 2023. You are given the task of testing the following hypothesis. There is a difference in tourist arrivals from the year 2022 and 2023. You're going to use the critical value of 5.991. So here are the data values, tourist arrivals for 2022 in cruise ship P, QRS respectively. You have 7698, 8017, 10,032, 12,015 respectively. And for 2023, 897, 6009, 981, and 9096 respectively. So we are going to week 9 to see how we can do a chi-square test for variation. So we go to the Google Classroom CI3QYBO, we go to classwork, and we go to weekly notes, Word and PDF format. We can use the PDF format, weekly notes number 9. Here it is, hypothesis testing, to get the steps for a classical approach for chi-square test or any test in general. So here we have the general steps to perform any hypothesis test using a classical or critical value approach. So first we have to state a pair of hypotheses. For the chi-square test for variation, this test deals with comparing two sets of values, the historical or expected values and the current or observed values. So the HO will be saying the observed values are equal to the expected, and the HA will be saying that the observed values are not equal to the expected values. So let us customize this to our example. So here is our pair of hypotheses. The HO is saying that there is no variation in the tourist arrivals in the year 2023 compared to that of the year 2022, or the expected, the observed is equal to the expected. And the alternative is saying that there is a variation in tourist arrivals in the year 2023 compared to that of the year 2022. In other words, that the observed are not equal to the expected. The step number 2 says to sketch a distribution curve. For the chi-square, it will be skewed to the right. And step number 3 says to locate and shade the critical region or the rejection region. The critical or rejection region of the chi-square test is always on the right side of the curve. Here you can see it. And step number 4 says to place the critical value on the critical point. So now we can use this as a template, this curve here, and we can plot the critical value on the critical point. So here you have it. Our skewed to the right curve, the critical region is on the right and the critical value is on the critical point and 0 at the origin. Step number 5 says to calculate what you call a chi-square test statistic. Here's the formula for the chi-square test statistic. The sum of O minus E all squared divided by E. O is the observed values and E is the expected values. For the chi-square test for variation, the historical values will be the observed values, will be the expected values, and the current values will be the observed value. So the values of 2022 will be the expected, and the values of 2023 will be the observed, and we can use Excel to help us with this formula. So as you can see here, we made use of Excel to help us calculate the chi-square test statistic. Here you have the observed values in this column, the expected values in this column. And here you've got the chi-square contributions, 4 of them, and the sum thereof will give us the chi-square test statistic. Now, according to week 9 hypothesis testing, for any hypothesis test using a classical approach, after you have calculated the chi-square test, the test statistic, be it z or chi-square, that's what we are using now with this example. You plot the test statistic on the distribution curve. There must have been a value already, or two values, 0 and the critical value. So you've got to use these as reference points to plot the test statistic. Clearly, 15,000 is much greater than 5. So that is very much to the extreme right of 5. This curve is not drawn to scale. Once we have logically allocated 15,386.55, and as you can see, our test statistic is in the critical region. The next step is decision time. It says reject the null if the test statistic is located in the rejection or shaded region. Do not reject the null if the test statistic is located in the unshaded region. Two types of errors can be made. A type 1 error occurs if the null is rejected and it could be true. So it could have been true, the null could have been true, and then we end up rejecting it. So that could have been a type 1 error. A type 2 error is if the null is not rejected and then it is false. Okay, so but for now, we have to know that we reject the null if the test statistic is located in the rejection region. If not, we do not reject the null. So let's see where our test statistic is and what do we do with the null. So as you can see, our test statistic of 15,386 is in the rejection region. So therefore, we have to reject the null. So our decision is to reject the null hypothesis. And the conclusion now, if the null is rejected, then the alternative statement is the conclusion. If the null is not rejected, then the null itself is the conclusion. Always remember that you will start the test with two statements, the null and the alternative. After the test is done, only one will be the conclusion. And you've got to write this conclusion in worded form. So we have rejected the null statement. So therefore, the alternative statement is the conclusion. And for this now, we've got to quote what the alternative is saying as the conclusion. So as you can see for the conclusion, based on the data, there is a variation in the tourist arrivals in the year 2023 compared to that of the year 2022. And just by a simple inspection of the data, you can see that there is a difference. Okay, so the difference appears to be significant, and the test has proven that.